This is beginning of chapter 7. We are going to look at addition formulae and using the addition formulae. So these are the addition formulae. They are quoted in the formula booklet. But as a start, it's a nice idea to actually do a proof. So what we can do is imagine that rectangle, and inside the rectangle, you've got a right angle triangle and another three right angle triangles in the corners. Let's imagine this angle here is alpha, and then let's have this one as beta, and we're going to assign that side here being of length 1. Then what can we write down for certain? So let's just have a look at that triangle with beta. So let me just redraw it for you so there's no confusion. So if that's my triangle, I flipped it, and so beta is here, right? And the hypotenuse is equal to 1. So if this is the opposite and this is adjacent, if I ask you to work out what opposite is, you would do, well, the function using opposite, you would do opposite over 1 is equal to sine beta. So that gives me opposite is equal to sine beta. So that will be sine beta. So let me put it here. Let me just use a different color. That's going to be sine beta. Now doing the same with a, you've got a over 1 is equal to cos beta. So that gives me a is equal to cos beta. So let's put it here. That side here is cos beta. Okay. Now we've got this triangle with a, with alpha. So let me draw it again. Actually, I'll draw it like that. So what do I know about this triangle? Well, I know this angle is alpha. I already know that the adjacent side is cos beta. There you go. And no, that's hypotenuse, not adjacent. I do apologize. This is the opposite and this is the adjacent. Okay, so let's find what is the opposite over hypotenuse, which happens to be cos beta. Well, that's going to be equal to sine alpha, because opposite over hypotenuse is sine alpha. So that opposite is equal to sine alpha cos beta. So let's write it down. Opposite here is sine alpha cos beta. And if you do the same with a over hypotenuse, so a over cos beta, that will be cos alpha, giving me a is equal to cos alpha cos beta. There you go. Okay, what else do I know? Well, I can work out this angle here. Okay, so what is this angle? So let's just take our time really carefully with this one. Let's do it in blue. Okay, so if this angle is alpha and this one is 90, then this angle here, this is going to be 90 minus alpha. So you've got 90 minus alpha, then you've got 90. Then what would this angle here be? Well, this angle here is going to be 180 minus that 90, and then minus that 90 minus alpha, because they add up to 180 on a straight line. So this is going to be 180 minus 90 minus 90 plus alpha. They cancel, so that's alpha. So this is actually alpha. Okay, so we are going to do exactly the same as with this triangle, but with a hypotenuse being sine beta. I'll do this one a little bit quicker. So what is this side? Well, this is going to be sine, well, it's opposite over sine beta is equal to sine alpha. So it's going to be sine alpha sine beta. And this one is adjacent over sine beta is equal to cos alpha. So adjacent is going to be cos alpha sine beta. There you go. So last triangle to consider. So last triangle to consider is the one over here. What do we know about this angle? Well, this angle is 90 minus those two added together. So you've got 90 minus alpha plus beta. So this one has to be alpha plus beta. So this one again should be quicker. Opposite over 1, that gives me sine. So it has to be sine alpha plus beta. And doing the same, this is cos alpha plus beta. That's what happens when the hypotenuse is equal to 1. Okay, so look at the sides. What are we trying to prove? We are trying to prove that sine alpha plus beta is equal to this. Well, look at that side of the rectangle. This side has to be equal to these two added together. So sine alpha plus beta must be equal to this, which was in red, sine alpha cos beta plus cos alpha sine beta. And then if you look on the opposite sides that are vertical, we were interested to finding out what cos alpha plus beta is equal to. Well, that's equal to that red bit here minus that blue bit. So it's cos alpha cos beta minus sine alpha sine beta. So this is a nice proof. There's another proof also that looks at geometry. Have a look at the different proof in the book, but I think this one is nice and lovely.